Problem 5.2 says, at one time the domestic gas used for cooking, called water gas, was prepared as follows. Water vapor with graphite yields carbon monoxide gas and hydrogen gas. From the thermodynamic quantities listed in Appendix B, predict whether this reaction will occur at 298 Kelvin. If not, at what temperature will the reaction occur? Assume the heat of the reaction and the entropy of the reaction are temperature independent. We first want to find the heat of the reaction by subtracting the heat of formation values of the reactants from the heat of formation values of the products. Since hydrogen gas and graphite are naturally occurring states, these values are 0. We can then plug in our values from Appendix B, and we get a heat of reaction of 131.3 kilojoules per mole. To find the entropy of the reaction, again, we subtract the values of the reactants from that of the products. When we plug in our values from Appendix B, we end up with an entropy of reaction of 134.1 joules per moles Kelvin. To determine whether or not the reaction is spontaneous at 298 Kelvin, we use our Gibbs energy expression and the values we just calculated. When we do this, we end up with positive 91.3 kilojoules per mole. This means that the reaction is not spontaneous at 298 Kelvin. To find the temperature at which the reaction will occur spontaneously, delta G has to be less than 0. We can say that the other side of the equation is less than 0 and plug in our delta H and delta S values to find the minimum temperature at which the reaction will occur spontaneously. When we solve the equation for T and plug in our values, we end up with T is greater than 979.1 Kelvin. So any temperature above this value will give us a spontaneous reaction.